Okay, so my name's Jeff Keister. I'm the field application engineer for EDA Direct. One of the products that I support is the PADS Professional Suite. I work for EDA Direct. We've been in business since 1997. We handle all your engineering tools in Southern California, Nevada, Hawaii area. And today we're going to talk about PADS Professional. Okay, I'm going to do a quick PowerPoint on this because I know some of you are anxious to understand and learn about the rigid flex. So with the PADS Pro platform, you're going to be getting component management that comes with it. There's going to be part quest and data book management. There'll be schematic capture tools that will come with the software. You'll also have constraint management tools, layout tools, 3D capabilities. You'll also get thermal analysis with hyperlinks, and you'll also get signal integrity pre and post design with out of hyperlinks that will come available with the tool as well. So this is all included in the setup tool for the Pro, but there's also other capabilities that you can use to add on, make your the software even more powerful. So we have a multi-trace router that's available, which allows you to route differential pairs, match lines very quickly and easily, and then tune those. We've got FlowTherm XT, which allows the mechanical group to be able to look at the flow and the heat capacity within an enclosure of when the board is inserted. We've got an ECAD-MCAD collaborator that allows us to talk from PADS Pro to Pro-E to SolidWorks, Solid Edge. We've got RF capabilities for you as well. And what we've also pulled out of the hyperlinks tool is 3 other features that are available so that you don't have to purchase the hyperlinks. We've got DDR analysis. We've got electrical design rule check for DRCs to be able to check your impedance differential pairs, where you might be having lines crossing multiple power planes, more of an electrical check. And then we've got also DC drop to be able to check your voltage planes to make sure you've got enough current running through those planes consistently throughout the plane. And then what has been added is the new rigid flex. So this is something we'll talk about at the end of the webinar. I think there's a lot of people that are excited that this has been added to the tool. Now this rigid flex is only available in the PADS Pro and in the Expedition tools. One of the first things we want to talk about is libraries. Libraries are pretty important. We can migrate your existing library, but you're also going to have libraries that are available to you right away. So you're going to be able to download the ODA library that's available on pads.com. There's 10,000 library parts in there that you can use, as well as being able to use the Part Quest tool as well. So that is something that you can go ahead and join. It's easy to find it, partquest.com. You can join that and set that up completely. They've got over probably now 1 million parts that they've got. They're constantly building library parts. And what's nice about this tool is it works with the DigiKey catalog. Customers are able to search for their components in the DigiKey catalog, and if they find that they have a lead-free and RoHS compliant symbol next to the part that they're purchasing, that will let them know that they can actually download that right into their library. The footprint will be there, and the cell will be there as well that works with DX Designer and the PADS Pro software. All the information is going to be available there. You're going to be able to get component information, the tolerances, the packaging, the pricing, everything. All those properties will come across when you download the part and bring them in. And then you can, once it's come into your system, you can go ahead and add other properties onto that tool. If you don't find that part in there, there's also the Library Wizard that's available now in PartQuest. So if you need to build your own components, you can build those directly in PartQuest and then transfer those right into your library. So this is one way, to be able to get parts very quickly, very easily. You don't have to build them. You can generate those and pull those right into your standard or your development libraries. We'll be using what's called a central library. So this is where we're going to be able to store all of our parts, our symbols, decals, drawings, models, and we're going to maintain that library data consistently throughout the whole projects. We have a direct link from the central library right into your project, and we also have migration paths that can bring third-party libraries as well right into your into the management tool. Schematics. So you will be getting 2 schematics. You'll be able to have Logic will come with it, and also DX Designer. So those will be the 2 schematic tools. Be able to do a hierarchical design. You'll be able to do constraint-driven designs as well. So those will be able to appear in the DX Designer tool. If you're doing variant management, say you have a motherboard that you populate different ways to create different products, we can also manage that for you without you having to manually go in and create your own BOMs or mess with your schematics. Our software will automatically take those and generate new schematics and generate new BOMs should you have to use any kind of variant management. Component management as well. We'll be able to manage all your library parts and your components in DX Databook. It'll be easy for you to quickly search and locate needed parts. You'll be able to verify the parametric data that comes with it. You'll be able to see what the cell's going to look like. You'll be able to see what the footprint's going to look like, which is going to eliminate a lot of the errors that you have searching for components inside of your library. So we have a full component management tool that comes with the schematic software. And you'll also have signal integrity analysis tools. So using the DX Designer tool, you'll be able to push your signals right into hyperlinks. So you'll be able to verify transmission lines, termination strategies, find out if you've got ringing or overshoot or undershoot on some of your nets. And this can all be done at the schematic level. You're also going to be able to do that in the post layout of the simulation and analysis tools. So should you lay out your designs and you want to, for example, find out if a clock line is causing you some problems, or maybe you didn't even lay the design out, maybe you used a service bureau, and this is going to be a way for you to check to find out if your designers were laying out the signals that you wanted properly. So you'll be able to do this both pre and post analysis, for your designs. Comes with it right out of hyperlinks. As well as you're going to be able to do thermal analysis. You've made sure that the properties that are on your components have the temperature range. We can also go in and we can have it set up to check for if you've got components that are going to be too hot. Do we need to be able to add heat sinks to them? Do we need to add like mounting holes around there to try to cool that area, spread components out? So there's going to be a nice thermal analysis tool that comes with it. Constraint management is going to be a really nice tool that's been added. Before, you were having to go in and do a lot of pull-down menus to be able to add all your constraints, and you weren't able to get them into the schematics. But now with the new PADS Professional, you're going to be able to have a centralized tool that's going to manage all your constraints. And this can be done in the schematic as well as the layout tool. And we can back and forward annotate that should we decide to make any changes while we're in the middle of the design. It's an easy to use form. It's pretty much set up as an Excel spreadsheet. So you'll be able to set up your classes, all your rules, your min-max line lengths, your differential pairs. So you'll find this tool to be very easy to use and very easy to read when you're looking to find out what your constraints are on your designs. We'll also be getting layout and routing. So one of the nice things is planning and placement tool that comes with the PADS Pro. So a lot of times engineers will give you a schematic and ask you to create a hand-drawn, on a napkin, and they want you to create a schematic, nice and designer. What's also nice is that we can use use the planning tool in the schematic level to be able to push that into Pro, so that we're able to bring in planning, I guess what I call them circles, but the data will be located inside those circles of where we have all the different sections of our schematic. So our memory sections, our microprocessor, our buffers, our analog, we can actually place those before we start placing our parts to give us an idea of where we might want to locate those on the board. You'll also have hierarchical group placing. So if you have hierarchials that you've laid out in the schematic, and you need to push into those, we can do that in the schematic, and as well, we can use our planning, our group planning placement to be able to bring, if you have like an I/O section of a design, then you want to be able to bring all the components on there. You can actually just add this property called cluster, give it a name, and then put a window around all the components in the schematic. Once you push this into the PADS Pro, now everything will be inside of a little circle, all the components that are valued onto that schematic. Makes the placement a lot easier. You're also going to be able to have a placement component explorer. This is going to help you when you're placing your components, whether you're placing groups of components, whether you want to freeze them, whether you want them planned or unplanned. So you're going to have a component explorer that's going to give you lots of information of what the component is, the part names, and then help you to be able to locate where's the best place to place those on the board. You're also going to have a net line visibility in the Net Explorer. So not only a component explorer, but you're going to have a net line explorer as well. And so this is going to help you with being able to visualize what the connections are on your components. So we can, instead of having all the rat's nesting that flies all over the board, makes it very difficult, using the Net Explorer, we can actually pinpoint just the components that we want to see rat's nest and not have to worry about all the other lines that go through that, causing distractions on what we're trying to concentrate on. Layout and routing, you're going to have complete layout and routing for whether you're doing digital, analog, RF, mixed mode. It'll be constraint driven. It's got interactive push and shove capabilities, as well as auto routing capabilities. Very robust rules for hierarchical designs as well. You'll also be able to cross probe between your schematic and your board and hyperlinks. So you'll be able to do all those things. You'll be able to do physical reuse. If you've got designs that you want to reuse again, we can set those up in reuse. Again, we'll also be handling variant management. So should you have designs that, like I said, a motherboard that has multiple variations on it to create different products, we can manage that as well in the layout tool. We'll also have copper creation manipulation, and then interactive high-speed routing is going to come with the tool. One of the nice features of this is the sketch routing tool that comes with it. It's a lot different than just regular routing where you're routing one signal at a time. Here we can escape out of BGAs very quickly. We have different routing styles, lots of via patterns that we can use, and we can also, it's going to give you that more of that manual route quality to it. The router is very easy to use. You basically are going to select the nets that you want to route with, in the rat's nest, and then draw a path on how you want those to be routed. You can see here in the bottom illustration, they routed exactly in the same path that was drawn on how they want the designer wants those to be routed. It's user controlled. It's very simple to use. Like I said, you're just going to select the lines and then indicate how you want those lines to be routed. What's nice is that as well, we can route differential pairs. We've used the Z-axis rules as well. It's going to organize our nets lines very easily and be able to pull those out of the BGAs, in a nice, neat flow rather than having them all tangled. You can hear here is like what I'm talking about is like the BGA escape optimization. So you can see in here the before, it's going to see all the tangled lines because we haven't gone into the BGA and moved a lot of pin swapping or things like that. So you don't need to do that with using the sketch router. What it's going to automatically do is it's going to use its algorithm and untangle those lines automatically for you so that you can have the best location to route from BGAs to whatever components you're routing to without any vias. There are two types of routing styles that come with the tool. We can either route them packed, which is right here on the left-hand side, or we can route them unpacked, giving you a little more spacing. Maybe you want to route differential pairs, more of an unpacked, like what we've got here. We've got these nice and packed, which is really not how you want to route your differential pairs. So you can route those unpacked as well. It's going to spread those out for you a little bit more and allow you to be able to push and shove and also add in more lines in between while you're routing. So you've got two different kinds of routing styles. Then you've got 34 different kinds of combinations with via selection. So should you need to swap from one layer to another, you're going to be able to see all the different types of via possibilities. So in this little video, it shows that they're at a 45-degree angle. We can go ahead and we can stop that route, switch it to double row if we want those to be at 45. We can just Control Z, bring it back to the how we want the routes to become, select different vias. So there's 34 possible combinations that you can use to route your vias to make sure that you're not cutting off paths while you're routing. Quality of the routing is excellent. So it's just like manual routing. You're going to get really nice connections, especially when you're routing differential pairs. So you can see everything's nice and neat. You can push and shove if you want to make things a lot tighter, but it's really the quality of that routing is going to be, you'll find, surpasses any auto routing capabilities. Gives you more of what's like in a manual route. 3D capabilities as well are going to come with the tool. So you'll be able to split your screen just like you've done in the PADS tool. You'll have a 2D capabilities. You'll also have the 3D capabilities. It's going to have its own GUI. It'll also have its own display, colors, and layers as well. So this will be separate from what's in the 2D layout. We do support component placement. So for those of you that want to place in 3D, you can place your components in the 3D. You do have also the capability to place in 2D as well. What's also I like is instead of bothering the mechanical guys, we can actually bring in the enclosures right into the PADS professional tool, and we can do our own DRC on that to make sure that we've got enough clearance between the enclosure and the top of the components, or we can see the spacing between components. So there's a nice design rule checking that we don't even need to bother the mechanical guys, and we can run our own checks on these as well. All we need to do is get the enclosure from the mechanical group. There's advanced viewing, so you've got a photorealistic visualization tool that's going to allow you to actually look to see what the board actually will look like. The silk screen, the solder mask will all be there. You can actually increase the Z-axis scaling so that you can see what's going on the inside. You can scale this up to 15 times size. We can see what the via barrels are doing, whether we're doing blind and buried vias. So it kind of gives us an idea of being able to see what's going on inside of the design. And we can also do a cutting of the planes. So we can also use this to see different sections of it by cutting the planes to where we want to locate to find out what's inside of that board. So you've got a lot of advanced viewing options as well that come with the tool. You'll be able to use measuring. There's a measuring ruler that comes with it so that you can manually measure between, so let's say, the board edge and the face place of an existing board. We can check to find out what our minimum distance is between components. So there's a really nice little ruler to do some measuring with it. And we can also import and export step models. So we can import the enclosures, the brackets that come on it, all the components, and we can also export step models to give to the mechanical group so that they can also bring those into their mechanical tools for verification to make sure that everything's going to fit properly. One of the nice things also is you're also going to be getting exporting 3D basic printing with Adobe. So I like this tool because it's going to be able to give you the access in a PDF with some intelligence. We can click on there and find out what the name of the components are. You could use this in meetings, for example, or project with a project engineer or customers. It's going to allow that customer to be able to turn things on and off. Say you want to turn the enclosure off, you can turn the enclosure off. It allows them to rotate and get an idea of what the board's going to look like once it's inside the enclosure. So it's really nice to be able to give this, to your existing customers so they can see it, or use this in your project management meetings. Manufacturing preparation comes with this tool as well. So what's nice is you're going to be getting the drawing editor. You're going to be getting FabLink. So drawing editor is going to allow you guys to create your formats, your data sheets, your drill drawings, all your notes, as well as you'll also be able to do panelization, and you'll be able to create DFT, design for test. So there'll be a whole manufacturing preparation program that comes with the tool. And you'll find that if you need to do your own panelization, but I think you'll mostly use the drawing editor to create your formatted assembly and drill drawings. Also added is an archive management tool. So with this archive management tool, you'll be able to archive the data that you've generated. So for example, your Rev A's and Rev B's and Rev C's, we can archive those right into the archive management tool. And it's going to allow us to create snapshots. So an engineer can now come into this tool and, for example, wants to see the differences between Rev A and Rev B. He can do that by calling up the schematic of the board. He can run a graphical compare. It'll give him out a list of what the differences were. He can see those. It's also going to allow the engineer to be able to create kind of what-if scenarios. He can also put post-it notes to remind him on the next spin things that he has to take care of or the designer has to take care of. So there's a complete archive management tool that you can use, and I highly recommend it for those that that want to store their designs and have access to them very quickly. Okay, so now let's talk a little bit about some of the add-ons, the capabilities that come with the PADS Professional. I'll kind of go over these kind of quickly. We have an MCAD collaborator. So this is going to allow us to be able to talk to ProE, SolidWorks, Solid Edge. So we can talk back and forth using what's called this collaborator. It's going to create an IDX file, which is much more powerful than the way that you've been doing it before. You can just create a step model and send that over. But what's nice about this collaborator, it allows us to pick and choose what we want to send over to the mechanical group. IGES files end up taking all the data and sending it over, and the mechanical guys have to wade through all that information. Where now is I can pick and choose which components that I want to send over, the top and the bottom layers, and I can create this IDX file and then send that directly over to the mechanical group. They can bring it into SolidWorks, ProE, Solid Edge. They can manipulate the data and then send it back to me through the collaborator. So it's a real nice collaborator that works with the tool. I highly recommend it for those that are having to talk with their mechanical group back and forth. There's a multi-trace router. So this is going to be able to route your length constraint nets, hierarchical nets, differential pairs, match length lines. So you can automatically use the router to route those signals for you first and then go ahead and tune them all at the same time. Helps to make it easily set up and protect your net topologies, and helps to your signal screw so that we can eliminate as much noise canceling effects as possible. So the multi-trace router is a pretty effective tool to be using if you're doing a lot of differential pairs or match length lines. Of hyperlinks, they've pulled the DC drop and made it available to you. So should you need to check to find out, do I have enough circuits, maybe enough metal to make sure that my power or whatever voltage is consistent throughout the whole plane. This is going to go ahead and run its checks on it to make sure that that's there. You can see like there's a little bit of red here. We might want to add a little more copper in here so that we've got more of a flow so that our voltage doesn't drop at all. So that's what the DC drop tool is used for. There's Hyperlink's DDR 1, 2, and 3. If you're doing any kind of DDR analysis with those, you can resolve your SI impairments, check out for overshoot or undershoot or any kind of ringing before you that, or timing issues that you might have. And we can check all these out before we even start routing. So that's a nice little tool that's pulled out of Hyperlinks and made available to you, as well as Hyperlink's DRC. So this is more of a, not the DRC that comes with the PADS Pro, but this is more of an electrical check, checking EMI, signal properties, PI, checking for things like nets that might go over multiple power planes that might cause problems. Or maybe you've got too many vias on a clock line, for example. Or you've got copper that's floating in the area causing an island that might cause some problems. Or there might be stub links. So this is going to allow you to be able to go in and check all the different signal integrity problems that you might have on your design, more of a DRC check for you as well. And then RF tools, if any of you are out there and are doing RF and you're dealing with Agilent ADS, and maybe you want to do some simulation from your schematic with ADS, or reuse circuits, RF circuits that you've used on other designs. There's now full RF capability that works with the PADS Pro. And then Flex, the Flex circuit tool. So this has been added in version 2.3. You won't find it in the earlier version. So if any of you that want to start using the rigid Flex will have to move up to 2.3. Works really easy, and we're going to get into that more towards the end of the webinar. But we do have definitely rigid Flex technology as well. So let me summarize here. We have PADS Standard tool, but what's nice with the PADS Professional tool, when you purchase this tool, you not only get all the capabilities that come with it, you also get the PADS Standard Plus tool that comes with it. So you're basically getting two pieces of software for the price of one. So I just wanted to mention that, but you're definitely getting a nice package here when you buy the PADS Professional. Now one thing that I always get the question of, well, why is, if PADS Professional, is tied into the PADS tool, why aren't we using PADS technology? Well, what we're trying to do is, Mentor's trying to do is allow the Expedition technology to be able to use in the PADS world. So when you use the PADS Professional, you are not using PADS Standard technology, you are using Expedition technology. So it's a little more powerful. You've got the sketch routing, you've got the manufacturing prep. You're going to see a lot more capabilities within the PADS Professional tool. Rigid Flex will not be working with the PADS Standard Plus or the PADS Standard at this time. I'm sure that they're working on that, but right now it is working in the PADS Professional tool and Expedition only. And one thing I like to do is give a lot of information so that you can, at your leisure, go in and look at videos and check out a lot of information. So I like to let everybody kind of know where the resource information is. So you'll notice that we've got a lot of information and a lot of content on pads.com, where you can get white papers, technical papers, data sheets, everything. So if you go to pads.com, you can see what's there. As well as there's on-demand training. So when you purchase the software, you'll get 30 days free on-demand training. After that, it's a subscription fee, a yearly subscription fee, which will allow engineers or designers to have access to training manuals should you need some more training, while you're designing throughout the year. Another place to go to get a lot of information is Mentor Graphics has a YouTube page. So if you just type in and search for Mentor Graphics YouTube, it will take you to all the videos that are available. If you look on the right-hand side, there's Mentor Graphics PCB, there's PADS, there's Expedition, there's Valor. So there's a whole bunch of videos that you can find at the Mentor Graphics YouTube, as well as under pads.com. If you hit the resource tab, you're going to find a lot of videos that are going to give you a lot of information in that section as well. There'll be how-to videos, how to set up PartQuest, how to run the sketch router. So when you get some time, I would go into those two resources to check out a lot of content that's available to you. Okay, so that's the end of my PowerPoint. And so what I want to do here, I want to play a little video for you guys, and then we'll come back and talk about the rigid flex. So let's get this started here. This way you don't have to listen to my voice the whole time.
Welcome to the PADS Professional Overview, where you will see many of the advanced feature sets that will enable you to address your most complex of design challenges, and they are available today. Why wait for solutions from Altium Athena or Altium Designer 18 when PADS Professional is available now? New functionality, including OrCAD schematic and netlist-driven PCB interface, provides even more flexibility and allows you to take advantage of the advanced PCB layout functionality, including 3D placement, routing technology, RF design, flex-rigid PCB design, and more. While maintaining your front-end system of choice, no need to retrain all of your design engineers. Mentor Graphics, a Siemens company, now offers PADS Professional key and netlist support. Use an ASCII text file to drive professional layout from many tools. Some of the largest designs we see are actually driven by key and netlist, where the design is too complex to describe visually as a schematic. For new designs, however, use the integrated PADS Professional flow so that you can take advantage of cross-probing and front-end schematic constraint entry, among the other advantages and features of PADS Designer. The PADS Professional GUI has been optimized for usability, speed, and user customization by providing user-tailored display schemes. Simplify your working environment and create a personalized display scheme based on the task at hand. By starting with a standard template, you can define your own custom toolbars and default object visibility settings. In this example, enabling part reference designator and part pins, one can place and route without switching display schemes or commands. It's just a single click. By setting up your own toolbars, commands, and object visibility, you can personalize your environment to your heart's content, creating a highly intuitive, tailored environment for how you approach PCB layout. You can change toolbar content and location by saving this information to your display scheme. Schemes can also be saved externally to be shared with other users. The purpose of a display scheme is to simplify your working environment and design flow, with display schemes independently control visibility and selection of task-specific objects, such as routing and fabrication objects. Filter out the unnecessary objects and commands so you don't have to fiddle around with the GUI. You can now spend more time using the tool and not fumbling around with the GUI looking for that one setting or switch. Make sure to take advantage of setting up your display scheme's favorites bar. Set frequently used object settings to the top of the GUI in your favorites section in order to organize your workflow for quick access. Take control of your workplace by color-coding specific nets and net classes with individual trace, pad, and plane controls per layer. This is extremely useful for quickly visualizing ground, powers, and critical nets during breakout and floor planning. Declutter your workspace by hiding little-used objects within your task-specific scheme. Just right mouse button click on a display control object. These hidden objects are saved along with each display scheme and can be re-enabled with a toggle switch. The point is to minimize the number of objects you need to hunt through. If you can't remember where the exact object setting is, you can just start typing into display settings to search through the object list. Hit enter to go through to the next object. So why spend all this time creating custom display schemes? PADS Professional uses a context-sensitive select mode to drive operation of the tool, reducing the number of clicks in day-to-day usage. Depending on your task, you want the right objects visible and selectable. So a few hints of the tool. Use auto hide windows to maximize screen real estate. Keying commands can be accessed by just typing. Command suggestions are visible at the bottom of the dialog and update as you type. A few really useful commands are MS for move selected by coordinate, and PX, place snap point at exact coordinate. Strokes are really useful. Strokes, right mouse button drag, are available to be customized. A few helpful default commands are diagonal down to zoom in, or diagonal up to fit the board. Drawing an L launches display control. And again, all of these can be customized. Dim transparency mode allows you to graphically control dimming and transparency intensities on unselected, unhighlighted objects, while displaying all selected and highlighted objects at full brightness. These modes are especially helpful in tracking down the physical topology of a trace when cross-probing through a very dense area of the board. No longer do you need to disperse components at the board edge and drag them on. The circuit engineers can create component groups in Designer, which the layout designer can place, append, and use as guidance during floor planning and placement. You can quickly view, sort, and organize a list of the relationally structured components, preserving the engineering design intent to guide placement. You can quickly append these layout groups and create new hierarchical planning groups as you deem necessary during the planning phase, and push that information right back to the schematic. Component Explorer is a spreadsheet interface used during component placement that drives all placement and planning with PADSProFessional PCB. It allows you to place individual components or planning groups. Component Explorer consists of a navigator view, allowing the creation and management of hierarchical groups, as well as showing the status of each group within layout. With each planning group, include the master board group, a list of components is displayed that can be searched, sorted, and customized by property, allowing you to organize and strategize your placement of individual components and planning groups. You can enable cross-probing within Component Explorer and the board to quickly find components already placed. The selected component cell can be previewed before placement in order to guide your placement strategy. For example, you can view netlines only between marked components for easy selection with sketch route, or to help with orienting the placement of components in high-density areas. Component placement can be completed in a few ways. Place by schematic is still an option. By just clicking on a component in the schematic, the cell snaps to your cursor in professional layout. However, why not take advantage of the planning groups of relational components? You can still place the components one by one, or use the Arrange dialog to place the group of components in a spiral-like fashion. Placing by group allows for optimizing floor planning. Connectivity relationships are shown between planning groups to easily visualize the connectivity flow through the design. Get a view of how the design will be connected and plan the design's organization before any single component is placed in the design. The size of the planning group outline approximates the area of the included components so that you can visualize if the components will even fit on the board. Placing by hierarchical subgroups, or arrange all groups based on all layers or just one layer. The subgroups can be set to be placed on specific layers and angles. The placement algorithm uses Constraint Editor part clearances and the part grid. Setting a subgroup up for decoupling capacitors on a large ASIC or FPGA chip is a really handy trick to control placement to minimize the rearrangement of these decoupling capacitors. Just use a larger grid to spread out the components. Although designing in 2D is standard operating procedure in most design flows, you can't design a PCB in isolation. You are designing a system. With PADSProFessional 3D, view how the enclosure mounts to the PCB, identify complex component placement violations, and present a photorealistic product mock-up to the design team, including the enclosure. To ensure design success, a holistic view is required to look at optimizing earlier in the design process, the PCB orientation, component placement, and how the system is assembled. A 3D view can aid in this optimization process. A holistic design approach that left shifts design decisions early in the design cycle is required to ensure faster time to market before the system is ever physically created or sent out for prototyping. In order to streamline your design process, the same commands are available during placement in either 2D or 3D view, so that you can use the same process flow. While placing, view concurrently both the 2D and 3D representations of the part, and either drive or follow 2D view while using 3D. Connector placement is especially helpful to view in 3D to make sure you get the orientation correct the first time. PADSProFessional utilizes photorealistic solid models that can be used to verify component clearances when placing. The cell manufacturing drawing may not include all the finesse of the full 3D model, and it can be difficult to quickly visualize the orientation of a component. To ensure proper clearances between components, set up global and custom clearances between the specific objects and components. Perhaps a connector needs extra space on one side during insertion that is not represented in the mechanical drawing. By viewing the design in 3D, one can visualize how the PCB could be assembled or interfaced with. You are also running DRC verification checks before the system is ever physically created or sent out for prototyping, potentially reducing time to market by left shifting electromechanical issues earlier in the design cycle. When interfacing with other members of your team in manufacturing, it is best to come prepared with a visualization of the design. PADSProFessional makes it easy to view the design in 3D with photorealistic solid part models, while showing off internal layer routing and fanouts. Have complete control over what you see and reduce render time by turning on what is only essential. You can even extend the Z-axis of the board to look at through-hole components and their interaction with the internal structure of the PCB. Measuring is a simple right mouse button click away, making it easy to quickly measure between objects in order to check against potential clearance and assembly issues. Double-check connector placement in regards to the assembly and component offset from the board edge. By simply clicking once on the object of interest, the measurement tool automatically snaps to other objects when moving the cursor. Remember, you're checking the design before the PCB is sent out for prototyping, allowing for extra passes of verification. The purpose of all this is to minimize rework by catching placement or part choice problems earlier in the design cycle. Also, present your board outline with its 3D representation with 3D PDF or export the entire board as a step model. PADSProFessional is designed to reduce the number of mouse clicks when routing while simultaneously increasing the quality of routing with push and shove routines. The routing algorithms are designed to reduce rework by minimizing the number of meanders, jogs, and trace segments. This is achieved by implementing advanced gloss built-in routines. One of my favorite features to use when routing is the active clearance dialog. The active clearance bubble shows a blue shadow of the actual clearances around your cursor while interactively routing in real time. The clearance keepouts are easy to see while still providing enough transparency to not be distracting. Active clearance provides a quick visual feedback of available routing paths. It is also extremely helpful in identifying the clearances of objects that will prevent a trace from entering a tight space. Active clearance will reduce your frustration level in highly dense areas when traces just won't go through. Interactive routing supports 4 routing methodologies. We have real trace delayed, the recommended mode. Simply click once to start. If a path is blocked, the route will enter a shadow mode until the trace reaches open space and a valid push and shove routine is able to be completed. For large bundles of nets, this minimizes the amount of traces attempted to be pushed and shoved when interactively routing, and ends up increasing trace quality while reducing mouse clicks. I've also noticed in extreme cases of net density, this algorithm helps to improve performance by holding off on the push and shove routines. Next, real trace dynamic, where push and shove is dynamic and the algorithm does not wait for an opening to push. Like real trace delay, there's no need to click to auto-finish the trace, saving time by simply hovering the cursor over the target pad to auto-complete the route. This is a very powerful mode, and if you're not careful, you can overly push and shove traces. For complete control, there's hockey stick mode, albeit with a lot of clicks. 1 click for each segment with local gloss to smooth out and reduce unnecessary joints. Click on a previously laid traces to go back. Also, hockey stick mode supports curve routing mode. This routing mode is extremely helpful in routing exact traces with anchor points, especially with coplanar waveguides. Segment on click is very similar to hockey stick mode. It supports any angled traces as well as curve routing. The purpose of Sketch is to empower you with advanced, easy-to-use automation to route high-density, high-quality routes. The automation is in your hands to control and finesse. This is not an auto-router, it's user-assisted automation. You can quickly route groups of netlines in a high-quality manner. Just draw a sketch, a simple object to control the trace path, decide which netlines to route, or let the algorithm decide. Set the layers, via patterns, and the style of routes. Sketch Router can be applied to a wide range of conditions, including large groups of netlines or smaller groups of associated netlines that start and end in the same general area. There's a multitude of methods to get started. By simply drawing a sketch path and hitting F9 to sketch route, the algorithm will automatically select the netlines to route based on proximity of the start and end points of the sketch path. If you want more control, you can select the netlines of interest before drawing your sketch. You can sketch route in two styles, packed and unpacked. Packed, well, packs the routes as closely as clearances are set, using gloss to minimize trace segments. You can add meandering by drawing a longer sketch path, as the algorithm will follow the sketch path more closely than unpacked. This is useful for tight bundles of nets when you want to minimize free space entering or exiting the highly dense BGA. You should consider using the unpacked style if you're seeing unnecessary trace packing or hourglass shapes. And if you plan on doing manual tuning, you should consider using the unpacked style because the traces will be spread out. When using unpacked, the algorithm prioritizes reducing segments as opposed to packing the routes along the sketch path. By default, the sketch path is freeform. You may choose an angled sketch path using F10 toggle sketch style or right mouse button click toggle sketch style. The freeform path is best when you just want a quick path through a general area. The angled path is best for precisely placed straight paths with more specific control over meander and bend location. The routes tend to adhere more closely to an angled sketch path. Sketch is so fast you can quickly undo and redo the routing. Use Sketch as a what-if scenario. Sketch empowers you with intuitive automation that is under your control. If Sketch is used in conjunction with routing tools and applied to the appropriate conditions, total routing times can be significantly decreased without sacrificing quality. High-speed memory interfaces and other sensitive connections multiply design complexity. Designers need more advanced tools to meet tighter and tighter constraints. The PADSProFessional Multi-Trace HSD tuning option offers high-speed design features and automation to reduce design time by quickly defining, tuning, and reviewing complex nets. Multiple methods for tuning traces in your design are provided to quickly match lengths of high-speed routes. With the target length dialog, view constraint-dependent nets by selecting one net. Sort and view the longest net of the bunch to plan your attack. Cross-probe and select your nets of interest for manual tuning, or tune the bunch using auto-tune. Auto-tune uses the constraint definitions, providing a one-button tune that meets electrical delay requirements, enabling you to minimize rework and ensure your design will meet the most stringent timing definitions. Manual tune gives the designer more control to precisely add length to meet the most complex constraint definitions. Open up dense areas of the board to add length to traces where needed, while preserving existing tune structures. PADSProFessional comes with optional advanced RF functionality to tackle today's challenging multifunctional PCBs. More complex designs containing multiple different frequency RF blocks, highly sensitive digital and analog systems are all tightly compressed on the board, and they're becoming more commonplace. A tried and true method of laying down smart RF shapes that are parameterized and simulated in industrial standard RF design simulators is essential for design success. Don't waste time laying down dumb copper. Use a tool that understands that physical connections are not always a short circuit, contains smart clearances, and parametric descriptions that can be simulated. Don't manually export or import Gerber for simulation. The built-in synchronization wizard directly translates your RF design into Agilent ADS or National Instruments AWR, saving critical setup and processing time. This allows faster design iterations by changing, checking results, and changing again. RF circuits can be bidirectionally transferred to Agilent ADS or National Instruments AWR using the integrated link, eliminating manual data transfer and syncing for quick and easy simulation. Start the design in PADSProFessional or ADS. You can quickly connect RF nodes with meanders or curves. Let's move this RF microstrip line to add a meander. Using the key-in command, move selected and input a delta X. With the Add Meander dialog, let's add a manually defined serpentine, leaving the corner type as free radius to add curved miters. We could use miter here. Just click on the RF segment to start laying down copper. Each RF shape is parametrically described and can be edited. In this example, a miter segment is widened and the sweep angle changed on a microstrip radial stub. Just double-click on the segment of interest. Shield vias can be easily added to complex outline geometries with the Add Via dialog. Use Ctrl-Alt-V to open up the Add Via dialog using Stitch Contour with 2 rows of vias. Select the net name to be assigned to the vias. With the shape selected, just hit Apply. Custom clearances can be easily defined by the RF group using the RF group clearance editor. In this example, let's increase the plane to RF shape clearance. After hitting Apply, notice the plane data is dynamically updated. To control the exact copper shape clearance through the z-axis of the board, more clearances can be defined. In this example, let's change the plane clearance to a slightly smaller value than the same layer clearance so that we can see the change. The pink plane layer on layer 2 now has a clearance applied, exposing the green plane on layer 3. Another handy feature is the auto-arrange RF command. When placing RF shapes, don't bother connecting each segment, just hit auto-arrange to build the RF shape based on the schematic. The RF symbols are also included in the install. These symbols give the users a quick way to create parameterized shapes as a reference or use them as is. These ADS parameters are used to build the simulation model. These RF elements can be cross-probed between the schematic and layout. Market drivers of thinner, lighter, and more complex systems are driving the growth of flexible technology usage. The ability to fold, snake, and bend around an enclosure opens up the design space, so that the entire system is now open up for review and optimization, increasing the product's strategic competitive advantage, though you're left with how to visualize and manage the complex interaction of boards and assemblies. Mentor is here to help with the PADSProFessional Flex support starting in VX.2.3. Quickly visualize complex bends and the board integration with the assembly. Verify that bend areas are valid and that no part or connector interferes with something else in your complex origami-like circuit. A flex design requires a master stackup consisting of all layers to be used in the design. In this example, I have previously defined a flex cable with a top cover layer, a plane layer, a polyimide flex core, a signal layer, and a bottom cover layer. The cover layer aids in copper adhesion and scratch protection. Once the master stackup is defined, individual board outlines can be assigned their respective stackups from the master stackup. Stackups can overhang as long as they don't share common layers. Each board outline will have an associated route border that is used as a render fence for the plane data and as a trace keep out. To quickly generate the route border, a built-in tool is provided, Draw Generate Route Border. Next, let's define the flex region that will flex with defining a bend area. Go to Draw, Bend Area. Let's add the 3D view to visualize the bend area. 3D visualization becomes key to identifying component placement and clearance issues earlier in the design cycle, and is essential for faster time to market. This concludes this brief introduction to the PADS Professional design flow, covering the advanced features and necessary options in today's world of highly complex multifunctional PCBs. We covered the advanced GUI and display control settings that will speed up your day-to-day workflow, floor planning and placement management to avoid the old way of distributing parts outside the board, the benefits of 3D placement, and making sure you're aware of electromechanical clearance issues earlier in the design process. The auto-active routing algorithms of PADS Professional will aid in faster completion times with less rework due to jogs and meanders. The RF license will aid in streamlining your simulation and design flow with Agilent ADS. And lastly, use the Flex license to manage, view, and verify complex bending and assembly interactions.
Okay, I hope everybody enjoyed that. Turn up my volume a little bit more. Oh, it's already at 100. Okay, so now we want to talk a little bit about Flex, the new Flex feature that's added. I've got a little video on this, and then after I'm done, I'll show you a quick demonstration on how easy it is to add Flex to existing designs. So let's take a look at this.
Flex PCBs are used everywhere in industry, from digital cameras, hearing aids, pacemakers, to health trackers, and much more. A rigid Flex design typically consists of multiple interlayers of flexible circuits and rigid regions typical to everyday PCBs. These are often found in cell phones, LCD TVs, antennas, laptops, and many more applications. Expedition's Correct by Construction Flex design technology simplifies the creation process, allowing you to focus on optimized form factor and quality. Expedition does not define flexible regions by zone, but by board outline. You can individually define each stack-up per board outline, simplifying the setup and minimizing the impact of changes later in the process. Flex designs are electromechanical projects that require deep collaboration between mechanical and electrical engineers. 3D technology is especially important for Flex designs. You can quickly identify design issues, ensure bends are in the correct locations, and immediately validate your design, taking advantage of design real estate in all 3 dimensions. Mentor has partnered with all of the major MCAD vendors to provide true collaboration between ECAD and MCAD engineers. This bridges the gap between the 2 design domains and encourages collaboration throughout the entire design process to ensure that all design requirements are met. Not only can you validate the design in Expedition, you can collaborate and exchange data with the mechanical engineer using STEP or ProStep format. Collaborating on bend areas, multiple outlines, multiple stack-ups, bend properties, and more ensures that all requirements in the ECAD and MCAD domains are met. Flex designs have critical design requirements that must be met in order to ensure quality of the overall design. Before the data is sent off to be fabricated, Expedition provides robust, updated design rule checks to identify critical issues. The Hazard Explorer helps identify problems immediately, so issues can be corrected long before the design is sent out to be manufactured. Flex analysis is also fully supported within our integrated simulation toolset powered by hyperlinks. The bend area drives the 3D board mode, visualization, and DRC. Defining a bend area is absolutely critical in a Flex design. In Expedition, you can automatically detect if vias are placed in bend areas or if traces are not perpendicular to the bend area, which can cause reliability and other issues. Expedition provides dynamic plane class assignment to define the plane hatch. You will have the ability to easily define the plane class with a predefined hatch pattern or define a custom hatch angle needed for your Flex region. It is absolutely essential that the correct design requirements are met and the exchange of data from the designer to manufacturer is seamless and requires as little documentation as possible. Improved ODB++ allows users to add the defined rigid Flex regions and define the associated subset of the master stackup, thus allowing the manufacturer to fully understand the design intent. With Expedition's Flex design technology, you'll have the competitive advantage you need to significantly reduce design time, increase overall quality, and reduce schedule risk.
Okay, I know you heard the word Expedition there. But because PADS Professional is Expedition Technology, they haven't created a PADS Professional video yet, so I use the Expedition one, but it's the same technology. So with that said, let's go ahead and show you how easy it is to add flex. Here's an existing design, has some flex already assembled on it. You can see it was probably brought in by a DXF file and then made to look by clicking on the different parameters of it and setting it up so that we can make it more of a flex usable tool. What's nice is it's easy for us to be able to add our own flex circuitry as well. If we set up in here, we can go and look at the stack up editor. And you can see in the stack up editor here that we've got a list of the flex layer that we're going to be using here. So the cover, the top, we've got the flex, we've got the polyimide, the spacer in between, the other side of the flex, and then the cover bottom of it. So that's all set up in your layer stack up. And then to be able to come in and just draw, let's say we're going to just draw an easy rectangle in here. So I'm going to close that up. Let's put in a rectangle here, and let's make it about that long. Okay, and we'll zoom in here. And then what I'm going to do is double click on this, control double click. And I should be able to get a properties window and -4 to give me, and click on that, make that a 0 width, and make that a 0 width. Okay, so now we've got two boxes in here. Right now they don't have any kind of drawing object assigned to them. So what we're going to do is we're going to take the outside one, and it's going to be my board outline, and we're going to attach it to the board outline, which is there in red. Then we're going to take this other one, and it's going to be our routing area, and we're going to tie that into the plane. So by doing that, we can come in here and select the outside one, go ahead and make it a board outline, and we're going to select all. We're going to just select the layers that we want the rigid flex to appear on. So we're going to take the copper top, flex 8 polyimide, flex 9, and the cover bottom. Say OK. That's going to set that up. And then we're going to go ahead and select our routing area. Really easy to do. Here's our route border. We are going to go ahead and select that to, let's see here. Okay, let's route border, perfect. Outline all. Okay, layer 3. Okay, so now that we've got that in place, we can go ahead and add a component. So let's go to our place components, our component explorer, and let's zoom in here a little bit, zoom out, and let's grab a component here. Let's grab this one here, J600. We can rotate it 180 degrees, and then let's try that again. Move that back. What's going on here? Control Z. Let's bring it on again. Rotate it 180. And let's move it in there nice and tightly. Okay, so now we've added a component onto the flex tool, and then maybe we want to add some routing. I think we've got differential pair route in here that we can go ahead and hook that up and route that in there. Okay, and now, so now we've added a component into the design. We can look at this. It's split the ground plane for us automatically. We've got a differential pair line running through there. Okay, And now what we want to do is we want to add in a bend area. So we're going to come in here and we're going to draw a bend area. We can set up the parameters of what degree, what's the width that we want on the radius. So we can set that up, and then we can go ahead and plop in our bend area. Okay. Invalid in crosses. Shouldn't have been a problem. I don't know why we're not getting the bend area in here. Let's see if we do it without the bend area. Side 2. Let's see here. Let's try this one more time. I don't know why this isn't going in. Oh. Well, bend area should pop in there. Let's push it to 3D. I don't know why. Add 3D view. This will take a little while. It's on my computer. I don't know what I was doing there, but that's how easy it is to add in your rigid flex. This is going to take a little bit. It's going to read in all the existing components. By adding those in, you'll be able to see all the step models that come with the tool. Give that a minute here. Sorry for that. I just only have probably 8 megs of RAM on this computer, so I definitely highly recommend that you get as much RAM as you can when you're using 3D capabilities. And that should read in real quickly. Okay. And then with that, we can actually see what's going on in here. Let's move this window over. 3D capabilities. Let's look at the top. And then let's zoom in here a little bit. Now you can actually see how the rigid flex has been added into the middle of the plane layer, and you can go ahead and create those in any way that you want. You can read in DXF files. It's very easy to be able to add your rigid flex using the tools possible. Okay, so I'm going to look at my participants here, and I'm going to unmute. Does anybody have any questions at all that they might have? Let me unmute that. Anybody have any questions? No? All right, then. So for any of you that have any questions about wanting to get your hands on the PADS Professional tool, you can give us a call at EDA Direct, ask for your salesman. We can also get you guys eval copies on this so that you can play with this. For those of you that are using the existing PADS Pro tool, we can also get you an eval guide to help you start using the rigid flex should you need any of that. So I want to thank everybody for coming on today. I really appreciate it. I hope you're able to learn a lot about the PADS Professional tool, and now with the new rigid flex makes things a lot easier being able to add rigid flex to your designs. Thanks again, and don't forget to give us a call if you need any help or have any questions about the new rigid flex tool.